In this presentation, we're going to look at given 4 points, defining the cross ratio of those 4 points, P, Q, or S, as the cross ratio of P, Q, or S is equal to this object here. We're going to show that the cross ratio is invariant under the projective transformations x goes to x, the first one x goes to x plus L, second x goes to k of x, and third x goes to 1 over x, where k and L are scalars. That is, in variance, we have to show that the cross ratio of the primed points are the points after these transformations, the cross ratio of the primed points is equal to the cross ratio of the unprimed points. A couple of notes at the start. Two vectors are the same if they have the same magnitude and direction. I have two vectors here. The sketch shows them it's supposed to be the same length. Vector AB is the same as vector ST because they're both going in the same direction and they're the same length. So the same magnitude and direction, therefore they're the same. I have two vectors here, vector A to B and vector F to G. They are the same length but they're going in the opposite directions. So we say that the vector A to B is equal to the negative of the vector F to G. If k times the vector A to B, if we have k is a scalar and then k times A to B, k times the vector A to B is a vector in the same direction as AB but with a different magnitude. The magnitude is the absolute value of k times the magnitude of the vector A to B. So if the absolute value of k is less than 1, the new vector k times A to B is shorter than the original A to B vector. And if the absolute value of k is greater than 1, then the new formed vector is longer. Now, given 2 points P, x, the components x sub P, y sub P, z sub P, and the point Q with components x sub Q, y sub Q, and z sub Q, then we can form the vector P to Q by subtracting the components of the vector P, components of the point P from the point Q. For instance, then the x component of the vector P to Q is equal to x sub Q minus x sub P. And similarly for the y and z components. Now in vector notation, the definition, well, look at the definition for the cross ratio we have to work out. On the numerator here, this item here is r minus p. Now we're told that r and p are points. Therefore, we can interpret this as a vector. So r minus p is a vector. And from what we've shown here, illustrated here, the point r minus point p is the vector p to r. And likewise with the point s minus the point q, that forms the vector q to s. The point r minus the point q, that forms the vector q to r. And the point s minus the point p forms a vector p to s. And similarly, if we write the primed cross ratio in terms of points, and then that becomes in terms of vectors the cross ratio of those primed vectors. Now the first transformation we'll look at is the case of x goes to x plus L. I've written down the primed point here and how this is developed from what we've illustrated here, how the primed vector is the components of that. For instance, the x component is equal to the x sub r plus L minus then the minus the x component plus L, and likewise for similarly for the y and z components. Now, if we expand the brackets in this, so distribute the minus inside here, that the x component becomes x sub r plus L minus x sub p minus L, and similarly for the y and z components. Now it's plus L and minus L, so they cancel out. And what we're left here is the components of R minus the components of P. And all that that's from what we looked at earlier on here. What that is the vector P to R. So for the case of x goes to x plus L, the primed vector of P to R is equal to the unprimed vector P to R. Now likewise for the prime vector q to s, the prime vector q to s is equal to the unprimed q to s, the primed vector q to r is equal to the unprimed q to r, and the primed vector p to s is equal to the unprimed vector p to s. So we can write the primed vector cross ratio by applying these results here is equal to the unprimed vector cross ratio for the transformation x goes to x plus L. So for that case, we have shown that the cross ratio is invariant under that transformation x to x plus L. For the case of x goes to k of x, or k is a scalar, writing out the primed vector p to r, the primed vector p to r is formed by k times, taking k times the point r minus k times the point p, as shown here, and that written is k times x sub r minus k times x sub p. Now we can factor out that k. For instance, for the x component, it becomes k into x sub r minus x sub p, and likewise we can do that to the k, to the y and z components. And then furthermore, we can bring this k, the scalar, out through the brackets. So what we have is we have k times the r point, the components of the r point r minus the components of the point p, and that is exactly k times the vector, the unprimed vector p to r. So we've shown here that the primed vector p to r, for the case of the translation or the transformation x goes to k of x, the primed vector p to r is equal to k times the unprimed vector for the of x goes to k of x. Now applying this result likewise to the primed vector q to s, sorry, the primed vector q to s, the primed vector q to r, the primed vector p to s, we can substitute these into the primed vector cross ratio. What we have is then, but using the result, we've got each one is k times the unprimed. Those k's cancel out, and we can see that the primed vector cross ratio is equal to the unprimed vector cross ratio. And I see in my notes here I have actually made a mistake here, which that is I am missing the k scalar times the unprimed here. So the transformation of x goes to k of x, we've shown that the cross ratio is invariant for that transformation. For the case of x goes to 1 over x, I'm going to, for the notational purposes, the point p primed, the components of that is 1 over xp, x sub p, 1 over y sub p, 1 over z sub p, and I'm going to use the notation for the point p prime, that is equal to 1 over the unprimed point, 1 over p for the point r prime. The components of the point r prime is 1 over x sub r, 1 over y sub r, 1 over z sub r, and I'm going to use the notation r prime is equal to 1 over the point r. That's the r prime is equal to 1 over the unprimed point, which is r. And then forming the vector the primed vector p to r from the primed point r and the primed point p. The primed vector p to r is equal to the components of is equal to the vector formed with the components of the primed r minus the components of the primed p. And using this notation that I have here for the primed p and the primed r, the primed vector p to r is equal to 1 over is equal to the 1 over the unprimed point r minus 1 over the unprimed point p, and multiplying out to get a common denominator. On the numerator, what I get is the point p, which is unprimed, minus the point r, which is unprimed, divided by the product of the point r with the point p. Now in the numerator of this here, This is in fact the vector R to P. This is unprimed. This is the vector R to P. Now this R to P, the vector R to P, is the negative of the vector P to R. So I can apply this result to the primed Q to S, the primed Q to R, and the primed Q to S, P to S. Now going to the primed vector definition of the cross ratio, I can plug in for the results that we've obtained here. For example, I can plug in for for what we obtained for the primed P to R. This is what we'd obtained for the primed P to R here. I can plug that in, and likewise with the others, and I end up with this object here. Looking carefully at it, you'll see that, for example, this here is the S point, and the S point appears both in the numerator and the denominator, Likewise, the point P is in the numerator, and the denominator. The point R is in the numerator, in the denominator and the numerator, and the point Q is in the denominator and the numerator. These can be cancelled out, as I have done here. And writing that up, this is what we're left with. Now we have these negative signs, and they can be cancelled out. A negative times a negative is a positive. And that leaves us with the unprimed cross ratio for vectors. So we've shown here for the transformation of x goes to 1 over x, goes to 1 over x, the cross ratio for of the primes, that's after the transformation, is equal to the cross ratio of the unprimed. And this shows that for the transformation of x goes to 1 over x, that the cross ratio is invariant. And these then, if so desired, for all of these results can be rewritten back in the terms of point notation as opposed to vector notation. I hope that has been helpful, and thank you for watching.